Welcome to conceptual classes on organic chemistry. Today's class is the continuation of class 9 and it is 10th class. I have continuing alcohols and phenols and today is reactivity part. So before starting this thing, one important thing I am telling you that you first understand the way where reaction occurs and what are the things happening. Until and unless you know the fact, you will find the reaction very clumsy and tough. You see the technique. First of all, type 1. Reaction of alcohol where there is breaking of OH bond, and this is a type of the reaction basing upon which the reaction occurs are, say, very simple. This is not tough. I am not balancing the reaction. It is 2 like this. 2. I am not balancing the reaction. The breaking occurs. Here the metal may be sodium, potassium, aluminium, etc. We will take simple 1 or 2 type of reaction which are important for you and for your class or for exam point of view. So, tertiary alcohol, again I am not balancing the reaction, just you follow me. Aluminium tert butoxide. Name is aluminium tert butoxide. It is carboxylic acid, ethanoic acid, and alcohol. Very important type of reaction. And here I am here giving a steric because there is a bit problem with this bond breaking. Later on I will explain it, just to follow first. The bond breaking is not the same exactly I have shown, but as it is given in the chapter I am to show here, because it is a process which is called esterification and which takes place in presence of acid and alcohol in presence of concentrated sulfuric acid, and it is a reversible reaction. Its equilibrium constant is found to be exactly or more or less near 1, and that's why it is reversible. So one thing happens here, if you want to get the maximum yield of ester, we require to remove water more and more. So as soon as we remove water in the formation of ester, the equilibrium will shift towards right and more and more ester will form. In this point, there is another important point to be mentioned here, that the alcohol which is used in the reaction may be 1 degree, maybe 2 degree, maybe 3 degree, and sometimes in your class exam or in the entrance exam, it is very often asked what is the rate of reaction of alcohol in the process of esterification. Answer: rate of reaction is of the order this, and this is due to steric effect of nucleophile, because it is a nucleophilic reaction. More and more steric hindrance of nucleophile is there, less will be the reactivity. That I have explained. You may not understand what I tell. So within a very short time, I am showing you one thing, a short mechanism of the reaction. CH3, C double bond O, H. In the first place, it reacts with acids. So what's happened here? CH3, C double bond O, H, and due to the presence of this H enters here, we get this. So next part is nucleophilic attack. Ethanol is acting here is nucleophile. So in the last class I told you, when nucleophile attack, it get attached. Am I right? If base is there, it abstracts. Here nucleophile is attacking, so it will get attached to that carbon. So the thing appears, this bond withdraws in this way, and OC2 H5 H, it becomes plus, and OH H plus. Next step, bond inclined towards this and this breaks. And one step I am showing, there is one step more, and that removes and it goes in this way. So what we get here, CH3, C double bond O, C2, this way. My intention is to show the mechanism to make you understand why 1 degree is more reactive than 2 degrees than 3 degree. Even methyl is more reactive. If there is methanol, even methanol is more reactive than 1 degree. Later on I will tell you. In my carbohydrate chapter I have shown you the tense esterification process is there. Am I right? So here you see nucleophile is attacking here. This is the step from where we will explain this. So here nucleophile, if the nucleophile is 2 degree, the bulkiness of nucleophile appears. If it is 3 degree, again bulkiness appears, steric hindrance appears. More the steric hindrance, less is the attacking tendency. So 1 degree will easily attack this one, then 2 degree, then 3 degree. That's why 1 degree is alcohol is more reactive, then 2 degree, then 3 degree. Am I right? Type 2. two type of reaction. It is again very important and interesting. You minutely follow. This type of reaction where there are two types of breaking occurs. The two types of breaking, one is OH bond, other is CH bond. OH and CH bond breaking occurs in types of oxidation reaction. Oxidation type of reaction. Just I am showing you one example. CH3, CH, H, OH. Am I right? When you give oxidizing agent, oxidizing effect, oxidizing agent. So what's happened? Oxidation means removal of hydrogen. One hydrogen from O, other hydrogen from C. In my earlier classes, I have mentioned this thing. So what you get here is CH3, CHO. CH3, CHO means in short CH2OH, it changes to CH2O, and further on oxidation this become C double bond O H. Am I right? So my main intention is to show OH and CH bond is breaking. Here you see OH and CH is breaking, and you are getting one CH3, CH2OH becomes CH2 becomes C double OH with the breaking of H, OH bond and CH bond. In this way, like type of same type of reaction occurs. If you take the reaction type is of 2 degree alcohol, then if you use this one, what you get here, there will be loss of OH bond and CH bond, these two will be lost. Am I right? So you are getting CH3, C double bond O, CH3. These are nothing but the technique. You just follow the technique, you can answer each and every one. Now oxidation of 3 degree. So before oxidation of 3 degree, I am telling 3 degree oxidation is generally doesn't occur under very drastic condition. 3 degree oxidation may happen to take place. So what's happened? If 3 degree alcohol is oxidized under drastic condition or strong condition, this transforms into this, and this on further oxidation transforms into this. In general, 3 degree alcohol does not oxidized under strong and drastic condition, is oxidized into finally carboxylic acid, carbon dioxide and water. Next, another type of reaction, dehalogenation, dehydrogenation, reaction. Dehydrogenation reaction is a type of reaction CH3, CHH, OH. It occurs in presence of copper at 573 Kelvin. So here again this type of bond breaking occurs, and here you get here CH3, CHO plus hydrogen. So loss of hydrogen, dehydrogenation, and loss of hydrogen oxidation. So dehydrogenation may also be called as oxidation type of reaction. So there is same you can do CH3, CH, OH, CH3, It is a very important type of reaction, very often asked in a state or board exam. Okay, so what you do here, you remove these two hydrogen. Am I right? So you are getting CH3, C double O, CH3 like this. Now, very important fact and exception, and that exception is asked in your exam. What that exception is, that if you take 3 degree alcohol, this is the question very often asked. Minority follow, this is the question very often asked in your exam. If you use copper 573 Kelvin, here dehydration occurs, not hydrogenation, and this bond comes here. What we get? 2-methyl propene. So you are asked in the exam 1, 2, 3, 2-methyl propane to all when heated over copper at 570 degree centigrade. What happens? What is the product forms? Answer: 2-methyl propene is formed, and this is the exception, and this is asked in the exam. Next type of reaction is, third type of reaction is the breaking of CO bond. Important type of reactions, CO bond breaking. Number 1 is CH3, CH2, OH, HCl, concentrated ZnCl2, CH3, CH2, Cl plus dot dot dot. Same way, if you use 2 degree, we will get alkyl halide. Same reason, if you use 3 degree, we will get alkyl halide. My main motto here is to explain one of the very important thing, the name of this reagent. This is Lucas reagent. And when alkyl halide is formed, it is immiscible with water and gives turbidity. And with this concept in mind, principle in mind, we can very easily distinguish 1 degree, 2 degree, 3 degree alcohol. So what's happened here? 1 degree alcohol, this is Lucas reagent. Turbidity does not appear at room temperature, but on heating it may appear. Number 2, if alcohol is 2 degree and if you use Lucas reagent, what's happened? Turbidity occurs within 5 minutes, and if it is 3 degree alcohol, turbidity appears immediately. So with the help of this, we can distinguish Lucas reagent, we can distinguish 1 degree, 2 degree, 3 degree alcohol. That's why this is very important type of reaction. Again, same type of reaction. If you use thionyl chloride in presence of pyridine, you will get alkyl halide, sulfur dioxide, and this all will evaporate. In alkyl halide chapter you will find this once again, and this is very important process of preparing alkyl halide from alcohol from thionyl chloride. Am I right? Another important type of reaction of this type, or always bond breaking occurs, is of CH3, CH2, OH, concentrated H2SO4. All of you know it is a dehydrating agent. It will dehydrate water, but this is temperature dependent reaction, and at different temperature it gives different things, different products. So at 443 degree Kelvin it gives ethene, and at 430 degree Kelvin it gives ether, and at 383 Kelvin it gives ethyl hydrogen sulfate. So it is a temperature dependent reaction. The fourth type of reaction is again very important. You will find this reaction in phenol alcohol. You will get again in aldehyde chapter. You will get again in alkyl halide chapter. You will get this reaction. Haloform. I will do here iodoform reaction. Very important from entrance point of view, from class exam point of view, NCERT or both. So all type of alcohol does not react with iodine in presence of sodium hydroxide to give iodoform reaction, but there are some special criteria. In short, I will show you what are the type of the reaction or structure of the reaction with which an alcohol will give iodoform reaction. It is if the structure of the alcohol is of this type. Here there is a box. In presence of box, in the box, if you place H in the box, or if you place CH3, or if you place benzene ring, phenyl group, whatever the structure it will be, it will respond to iodoform reaction. Let us test. Say CH3, CHOH in the box. Let me place H. Means it is CH3, CH2OH, ethanol. Am I right? It is ethanol. Let's see whether ethanol responds or not. Yes, surely ethanol will respond. This is iodoform. I am not showing other part of the reaction. It will show. It is a yellow compound, and it will. When yellow compound is produced, we will blindly say that it has responded to give iodoform. Now, in place of, what is the implication of this reaction? Say this is methanol. Say this is methanol. This is methanol. In the exam, a question may appear: ethanol and methanol, which one is respond to iodoform reaction? Just can you fit ethanol here? No, ethanol will not respond. Now, if you place H here, ethanol will respond, but methanol will not. Now, in check with propanol or propan 2-ol. Let's see. CH3, CH, OH, CH3. Meet in propan 2-ol, and propanol means CH3, CH2, CH2OH. This is propanol, is it propan 2-ol. If it is in the exam, if a question appears, which one will respond? Let us see whether this responds to the structure 1. Yes, CH3, COH, H, and in the box CH3, CH, CH3, CH, OH, in the box CH3. So it has fit in the box, so it will show iodoform reaction. But you cannot fit this structure into the box, hence it will not show the iodoform reaction. Again, in the entrance exam, some benzene ring is there and iodine is there, sodium hydroxide is given. You are asked to write the answer. Answer will be CHI3. Blindly write the answer CHI3, because if fit this benzene ring here, again it will respond. It is a very important reaction. Iodoform reaction. Alcohol shows iodoform, not all alcohol, the alcohol of the type, this type will show iodoform reaction, and it is a very important technique to test whether a compound gives iodoform reaction or not. Next one is phenol. Phenol is very simple and very easy. Number one, phenol. First reaction will show HNO3, means nitration of phenol. One thing I have to mention here, that OH is ortho and para derivative. That ortho and para position, there will be electron density, and electrophile will enter in these two positions. If it is dilute, so nitro group enter in both the position. Once in ortho position and other time it is in para position. Number two, from the same thing I am showing you, if you use concentrated HNO3 and concentrated H2SO4, again you will get, it is a nitrating mixture, am I right? So here nitro group will enter, subsequently in 2, 4 and 6 position it is picric acid. This is picric acid. So nitration is over. Number two, halogenation. Halogenation reaction. Halogenation reaction is with bromine, and if is bromine is carbon disulfide solution, then bromine once will ortho, enter in ortho position, and other time bromine will also enter in para position. Now another important, very easy, phenol is very easy, just you follow me. If bromine, aqueous water is there, two, 4, 6 tribomo phenol, 2, 4, 6 tribomo phenol. Nitration, halogenation. Number 4, sulfonation. Sulfonation, it is very simple, and each and everywhere you will get this. This is very simple, nothing to explain. Oleum or concentrated sulfuric acid, you will get SO3H ortho and in para position. Mind that here electrophile is SO3, not SO3H. Mind that in exam, entrance exam, it appears of very often asked. Number 5, alkylation. Again, it is very simple. Anhydride aluminum chloride. Electrophile will be CH3, everybody of you know. And already I have shown you the structure. This is Kashrul, some important compound I mentioned. It is para Kashrul. Next is acylation. CH3COCl, anhydride, aluminium chloride. So we have got nitration, we have got bromination, we have got sulfonation, we have got alkylation and acylation. Very simple, not tough. And number 7, when phenol reacts with zinc, we get benzene and zinc oxide. Number 8, when phenol is made to react with this hydrogen in presence of nickel, it gets cyclohexanol. And when phenol is placed at Na2, CH2O7 is placed, is mixed with phenol in presence of acid, it gives benzophenol. And next, phthalic anhydride. Two mole of phenol phenolphthalein, phthalic anhydride. Phthalic anhydride, when made to react with 2 moles of phenol, it gives phenolphthalein. And very important compound phenolphthalein, when is made to react with sodium hydroxide, it gives phenolphthalein. For exam, entrance exam, this is a very important question. And phenolphthalein, in crime branch, the police very often used phenolphthalein in the form of amorphous form, powder form. They very often mixed the phenolphthalein powder over the notes, currency notes, and when a person take bribery, as soon as now you minorly follow the number 10 are reactions of phenols. These are all which I am going to explain you are named reactions. butyrar reaction, and this is phenol ammonia. This gives amine. And number 10, Cope's reaction. This is very important for state as well as NCERT and also any type of entrance exam. A critical type of questions asked from Cope's. First of all, I am showing you the reaction, and then I will explain some of the facts upon which questions are very often asked. Salicylic acid. It is very important type of reaction, so we please follow the steps of the reaction. Sodium hydroxide, phenol, sodium hydroxide, phenoxide, sodium phenoxide. And number 1, first place carbon dioxide is used, and after completion of carbon dioxide, acid is used. And if you just reverse the sequence, answer will be wrong. You can't get the answer because it is mechanism. It is proved through mechanism. So it gives salicylic acids. Salicylic acids. One thing I will explain it a bit later. Why phenol is treated with sodium hydroxide? Means OH group is there, sodium hydroxide is used. Again at last OH appears as OH. Now what's the use of this thing? Why we are doing this game? First OH is there, NOH is applied, again OH comes in its position. There must be some reason. And why carbon dioxide is first and acid is second? I will explain it on the basis of mechanism. Though mechanism is out of your syllabus, for entrance exams or other type of questions, you must know the mechanism. You need not practice the mechanism, but I will explain with the help of mechanism. You need not practice the mechanism. Number 2, 12, dimer, diamond reaction. Phenol, chloroform, sodium hydroxide or potassium hydroxide. You will get this. On treating with sodium hydroxide, it is actually aqueous. You will again get and that at the final stage you treat it with acid, you will get again phenol. It is saldehyde. Again we are doing the same things. Here OH is there, OH has been treated with sodium hydroxide, and then at last again you see OH is again coming. I will again explain what happens here. So it is very important reaction. One of the main important fact in entrance or state or NCERT level, what is the intermediate reagent is used. What intermediate? That is maybe carbocation, maybe carbanion, a reaction follows through this, am I right? So there must be an intermediate, and that intermediate is dichlorocarbene. You will never get this dichlorocarbene. Nowhere you find this, but answer is this I will show you in mechanism if I get time. Dichlorotoluene very often comes in the entrance exam. What is this? And here one question very often asked, what is electrophile? Nucleophile, electrophile. It is electrophile saturation, am I right? Here electrophile is carbon dioxide electrophile, and that electrophile is very weak electrophile. I will explain electrophile very weak. I will explain through mechanism. Electrophile is this. Here electrophile is attacking reagent, intermediate attacking reagent, in intermediate attacking reagent is CCCl bond lone pair. It is dichlorocarbene, CrCarbene, carbene. Am I right? Very, very important reaction. Sometimes in your board exam, that reaction is as a whole is given. You are asked phenol, CH3, sodium hydroxide, aqueous acid. You are asked to give the reaction. Sometimes it is given. You are asked to name the reaction. What is the name of the reaction? Number 13. Scott-Baumann reaction. We have done it earlier. Scott-Baumann reaction. That is again very simple. I will explain. This is phenol and benzoyl chloride. Am I right? And sodium hydroxide is used. You will get very often in entrance exam. This question is asked. The reaction is given, and you are asked what is the name of this reaction. Scott-Baumann reaction. And next one is Bauer-Blah reaction. This is not related to the reaction of phenol, but it is preparation of phenol. So I have just categorized all the name reaction in one place. That's why I have written it. You write in this way. It is reduced. It is ester. Ester is being reduced by sodium, and this, your answer will be CH3CH2OH plus CH3OH. Ethanol and butanol. It is one of the very important reaction. It is not in the syllabus of state level, and it is meant for entrance for preparation of alcohol. Bauer-Blah BLNC Blah reaction. And next one is RASCHING racing reaction. Again, this is a type of reaction which is not the reaction of phenol, but it is preparation. The same as this. This is benzene plus HCl plus O2 CuN2 ferric chloride, C6H5Cl, steam, means water in steam form, C6H5OH, phenol. It is preparation again, and this is the reactions in this time. The previous year in Assam higher secondary exam, science higher secondary exam, a question was asked what was the catalyst or reagent are being used in racing reaction, and it is also important type of reaction. You will find these reactions in alkyl halide chapter also, aryl alkyl halide. And next type of reaction is Gatterman reaction. It is reaction of phenol. Here, phenol reacts with HCl, HCl, aluminium chloride. You will find para-hydroxybenzaldehyde. So these are the some name reactions which are very often used in benzene, and another is not name reaction, but you know it very well. It is benzene diazonium chloride. Benzene diazonium chlorides, warm water gives you phenol. It is preparation, not reactions of phenol. Now let me explain some of the facts why and another and last reaction is very often you get phenoxide ion when treated with acid, we can get phenol. I am showing you one name reaction, Dow reaction. Dow reaction. Here what's happened? Chlorobenzene is treated with sodium hydroxide. It gives ONA, and upon reaction with acid it gives phenol. This is Dow reaction. And now let me explain some of the facts. You will find that all the reactions is not easy to keep it in your mind, but I think from my perception, I think until and unless you know the mechanism, these reactions will not be clear to you. So as this up to your level mechanism is not included in each and every name reaction, non mechanism is given in your text, so I think it is not essential for you, but for some competitive exam, you know some of the important facts, some of the important mechanism you should know. So without mechanism, chemistry is a bit hard. You should know, that is, you should not always based upon the facts to know the answer. You should sometimes know the mechanism. So let me take Cope's reaction. What are Cope's reactions? Cope's reactions was phenol treating with sodium hydroxide, sodium phenoxide, sodium phenoxide, and when treating with carbon dioxide and C, we got salicylic acid. Now let's see what actually I told you, that when phenol, first the use that we are using phenol, first we are converting it into phenoxide, then again phenol is OH is again coming. What the use of these things? Why we are doing these things? The fact is that I am showing first the mechanism. You first see the mechanism, and automatically you can understand. The mechanism is not important in your exam till I am showing the mechanism. Just to see the mechanism. This is phenol. Sodium hydroxide is there, OH is there. It is now acting as a base, and in the last class I told you, when base, the function of base is to abstract hydrogen, and function of nucleophile is to attack the carbocation part. It takes away abstract and the bond is withdrawn. What happened here is phenoxide ion. Now carbon dioxide electrophile. I told you it is weak electrophile. I will explain the fact. It will come here and that will attack here. So what will happen here is negative. Next, we have next after carbon dioxide in second place we used acid in our scheme of the reaction. That was when acid is there, water is already there, so water becomes protonic. That is, water will become H3O positive, means HOH2. We can write in this way. Am I right? So what's happened? HOH2 plus, and this takes this one. Am I right? Takes this. So what we get is C double bond OH. Am I right? So again water protonated, that hydrogen get attached with this. There is lone pair of electron. Am I right? So what you get is am I right? Positive. Next step, water is like this. This water extract this hydrogen and this bond gets here, and I'm sorry, here OH. It is not actually OH, it is O singly. Double bond O, double bond O, H. Am I right? So this bond withdraws. So we are getting the desired product. So why we have done this? Because you see, phenoxide ion is more stable, more reactive than phenol. Due to this ion, it gets delocalized in the benzene, the resonance occurs, it gets stability and it becomes reactive. Due to the reactivity of this phenoxide ion, it is weak electrophile and weak electrophile attacks. Without the use of sodium hydroxide, you cannot directly make reactions with phenol and carbon dioxide. Carbon dioxide weak electrophile, phenol cannot facilitate to introduce carbon dioxide in the ring. So it is weak electrophile, and due to the strong reactivity, more reactivity of phenoxide ion than phenol, that's or carbon dioxide is introduced in the ring. This is the reason why we are using sodium hydroxide first and again OH is coming. This is the reason to get phenoxide ion is more reactive than phenol. Am I right? And more due to the more reactivity of this phenol, the weak electrolyte get introduced into the benzene ring. Now, that's why I told you at the very first you should use carbon dioxide. Yes, we have used carbon dioxide, and second step we are using proton, means acid. When we use acid, so water becomes in this way, reaction further process. So you should not alter the sequence of the reaction. So this is the reason why sodium hydroxide is used in with phenol, and finally again OH is coming in order to make the phenol more reactive to attract C-double-O2, and it will be introduced in the benzene ring, and finally we get the answer. So it is electrophile. So this is all about the reaction. One reaction I have forgotten, very important. I have just effaced out the name. I don't know the serial of the reaction. Very often comes in entrance. Very often. This is phenol, and reaction is given FeCl3. Maximum of you cannot answer this one. You see, this is H plus Fe it is a complex and biological. This is very important reaction, and it is a very important reactions of distinction between alcohol and phenol. Am I right? When you treat ferric chloride with phenol, it gives violet color due to the formation of this complex. However, and in entrance exam, the structure of the complex is asked. What is that complex? That's why I have shown you. And how we can distinguish phenol with alcohol. With phenol, when reacts with ferric chloride, it gives a complex whose color is violet, whereas C6H5OH or alcohol doesn't react readily with FeCl3 to give any color. This is one of the important distinction test in between phenol and alcohol. This is all about the reactivity of alcohol and phenol chapter. Hope you have enjoyed the class, and very shortly I am trying to make another class on physical behavior or the order of acidity, basicity, alteration of acidity, basicity. Lots of questions very often asked in entrance, also you are in board exam. So this will be my last class on phenol, alcohols and ethers, and along with this I will solve out all the conceptual chapters questions answer along with proper and precise explanation. Thank you very much for watching the class minutely and patiently.